Okay, there are a couple of different ways to do a problem like this. I'm going to start with a little diagram showing where the two cars are. They're connected on a straight north-south line, and they're going to meet somewhere near the border between Oklahoma and Texas. So car B is 132 miles north, and car A is 75 miles south. So I guess the easiest way to do this is to use our equations: distance equals velocity times time. So the distance covered by car A is going to be A's average velocity times the time, which is 53 times the time. Likewise, the distance covered by B is going to be the average velocity times time. Now I used absolute value signs here and here because I'm only interested in adding up distances, not velocities. Normally in a problem like this, I might define this direction as positive and this direction as negative, which would mean that the B displacement, which points in this direction, delta xb, would be negative, and the A displacement would be positive because it points up. But in this case, it's easier just to add the distances because I know the two distances have to add up to 207. That is, the distance, delta xa, plus the distance, delta xb, is 132 plus 75, which is equal to 207. Well, that means that 53t plus 75t is equal to 207, right? So you see that little trick. That allows me to solve for t. So t is equal to 207 over 128, which is 1.617 hours. And now I can solve the problem pretty easily. For example, I can find A's displacement, delta xa, which is 53 times the time. That's 86 miles if I round off. And so that means delta xa looks like this. It's 86 miles, which is 11 miles north of the border. So the cars meet 11 miles north of the border. You can also, just to double check, you can find delta xb, and in this case delta xb, I'll just calculate the magnitude of it, is 53 times, oops, does A move? Right, sorry, yeah, that's right, so sorry, B is moving south at 75 miles an hour. Sorry about that. I got myself mixed up. 1.617. So B travels 121 miles. And that makes sense because the distance to the border is 132 miles, so B ends up 11 miles short, which is 11 miles north of the border. So that checks out. The distance, delta xa plus delta xb, does indeed add up to 207 miles, as it should. Now, another way to do this would be to put yourself in A's shoes and consider yourself as traveling with A. So from car A's perspective, you can say that car B is 207 miles away, and it is moving with a relative speed. We have to add the speeds together, 128 miles per hour. Right, so if you're sitting in car A and car B hits you, the relative speed is going to be 128 miles per hour. From that, you can get the time. Time is equal to distance divided by velocity, and that gets you your 1.617 hours. Right? So those are two different ways to approach that one.